So for this reality check, we'll be using just operations with fractions, and I think there's some mixed numbers in this as well. So let's read the problem here. A competition barbecue club is planning on making and selling barbecue apron sets as a fundraiser for a charity. They plan on selling them at their competitions this season. There will be an adult-sized and a matching child-sized apron in each set. Each adult apron takes 2/3 of a yard, and each child's takes 1/2 yard. One club member's family owns a fabric store and can give the club a great deal on 5.5 bolts of outstanding fabric. Each bolt contains 15 yards of fabric. So there's a few different pieces of information that seem like it's going to be crucial for this one, just without seeing the rest of the problems, right? Is we got an adult apron and a child apron. Now, they're sold in a set, right? Each in each set. So I assume we're going to have to add these together. Now, 5.5 bolts of fabric, and a bolt contains 15 yards. Okay, so we'll keep all this information in mind as we look at the question. So number one, calculate the number of apron sets the club can make from this fabric, and we'll show our work below. Now, number two is going to show a few different scenarios. Let's go through this kind of piece by piece to figure out how many sets can be made from what is 5.5 bolts of fabric. Okay, so the first thing I would do on this one is I would say one set. How many yards is it going to take to make one set? Well, you have an adult apron, and you also have a child's apron, and the adult is going to take 2/3 of a yard, where the child's is going to take 1/2 of a yard. So if we add these together, we'll figure out how much of a yard, or how many yards, it will take to make one set, right? So I'm just going to put this in the calculator. 2/3 plus 1/2. 7/6. So 7/6 yards of fabric in one set. So that's one set. But the other thing we want to know is how many yards of total fabric are we getting, or is this club getting, right? So how do we figure that out? Well, a bolt is 15 yards, and we have 5.5 of them. So that's 5.5 groups of 15 yards, which means that is multiplication, all right? So that may or may not simplify. You can just add it. So 5.5 times 15 yards, and this will tell us how many yards of fabric this club is going to get. I'm going to put that in the calculator. So this shows 165 halves yards. Now I'm going to keep this as an improper fraction just because we're going to continue to operate with these, all right? So now that I know how many yards the club is getting, and I know how many yards are in one set, the question is, how many sets can be made from the fabric? Or, in other words, how many of something goes into something else? Which makes it a division problem, right? So I'm going to take how many yards we have, 165 over 2, and I want to know how many 7/6 are in it. So I'm dividing that by 7/6. So again, to figure that out, I'm just going to put it into the calculator, and this will tell me how many sets I can make from this amount of fabric. So let's put it in the calculator. So I can make 495 sevenths apron sets. Now that doesn't really help us. So, and I'm not saying it wouldn't work for this. Okay, it's just, it would be more helpful if I could see this answer as a mixed number, which would tell me how many sets I can make, and then maybe part of a set, right? So let's change this into a mixed number. I'm just going to use my calculator again. So that comes out to 70 and 5 sevenths. But again, this is a word problem, so I want to make sure all my answers are labeled 70 and 5/7 sets. And you could put sets of aprons, but I'm okay with just sets on this, all right? So we've shown all the work. We've shown how many yards is required for one set. We've shown how many yards the club is getting. And then we've shown the division here because it's how many of something goes into something else. So 70 and 5/7. Let me explain this in a little bit more detail. So there's 70 and 5/7, 7/6 in 165 halves. Maybe that made it worse. Hopefully not, though. So we'll keep that information above, right? So we got number 2 says 3 of the following complex fractions will calculate how many apron sets can be made. Which one will not? Now, it does say to show all your work on all 4 options. Use a separate sheet to show all your work. So don't just say, well, the answer is A, and just leave it at that, okay? Or I definitely don't just put, I typed it into a calculator, and then that's what it gave me. Even though, I mean, that would be a form of doing the work, but we want to show the work for this, okay? And we'll work through this piece by piece, all right? So, like we would with a regular fraction, I would just be looking to simplify the numerator. And again, I'm just typing this all into the calculator. So 15 times 5 1/2. And then in the calculator, we'll put the 2/3 plus 1/2, which again, we typed in already. And it shows that it is 7/6. So when we divide these, 165 over 2 divided by 7/6. Well, that's when we got that improper fraction of 495/7, which came out to 20 and 5/7. Okay, so that was the answer that we got in number 1. Excuse me. Both the improper and the mixed numbers. Okay, so that confirms A is the same. Okay, so, and we've shown all the work for that, and that's good. Let's go to part B, though. So we got 15 times this value. Now, remember that it's really just fraction multiplication on this one. So I would show this as 15 over 1, which means I'm multiplying the 15 by 11 over 2. All right, so let's put that into the calculator first and see what we get. 15 times 11 over 2. And this is all over, look, 1 times whatever the denominator is just itself, right? And we already know that 2/3 plus 1/2, well, actually I forgot, it's 7/6. There we go. 7/6. All right, now I kind of did skip a step there, right? I don't really need to show that 1 times 2/3 plus 1/2 is 2/3 plus 1/2. Okay, so I don't really need to show that, so I just show it's 7/6. Well, 165 over 2 divided by 7/6, that's the same thing that we got on part A, right? So I know that that is going to equal 495/7, which could also be written as 20 and 5/7. I apologize. Yeah, it should be 70 right there. And right here as well. I'll erase that garbage. I guess it won't let me. It should be 70 and 5/7. That's better. Which is the same thing that we got on number 1. That's better. Now, just to double check this work, right? We could type it in exactly like we see it into the calculator, which will confirm that we've done the math correct, which I probably should have done the first one as well, because it's not 20, it's 70, which the calculator also shows converts into 70 and 5/7. So we did that correct. All right, but let's look at C then. So this one is 15 times 2/3 plus 1/2. And we already know that this 2/3 plus 1/2 is 7/6. So just rewriting this problem now. I got 15 times 7/6 over 5 1/2. So 15 times 7/6, that's going to switch this stuff up. Looks like it'd be 35/3. So I just did that by hand just because it was faster than putting it into the calculator. And 5 1/2, that's going to be 11 halves right there. So we'll put this into the calculator though. So this comes out as 70 seconds, 33rds, sorry. 70 33rds. Well, that's not the same as the fraction we got before, which was that 495/7 there on the left. So this one's not equivalent, right? This one is not the same. But it did want us to show the work on all four parts, right? So as of right now, we know that C, this one's no good, okay? But let's do D, just to, again, kind of confirm. It's 15 times 11 halves. What do we get on that? 15 times 11 halves, and the calculator would show that is 165 over 2, and that's the numerator. And then the denominator, again, we've been seeing that 7/6 happen often, so it's over 7/6, which is the same as what we got after simplifying A, well, and B as well. So this ends up, if we were to put it into the calculator, would be, well, I'll use a different color here. It would be 495/7, or as a mixed number, 70 5/7. So let's go back to the question here. 3 of the following complex fractions will calculate how many apron sets can be made, which one will not. And we can already see that the answer to that one is C. Alright, so C was very different, and we should notice that it's different just based off of what we know now about operations with fractions. So number 3, look at the complex fraction expression above that came up with a different result. Explain what is different about that expression. Alright, so what is it that is different? And again, we should know the answer to this just based off of what we understand now about operations with fractions and even just the basic operations, right? So the 2/3 plus 1/2, that came from this top pointer right here where it says each adult apron is 2/3 of a yard and the child's takes 1/2 of a yard. So that would tell us how many yards is in one set. Okay, now 15 is how many yards are in a bolt. Okay, so if I were to analyze this, it would be like saying I got, just with the labels even, I've got yards per bolt, and it doesn't matter how many yards, multiplied by how many yards are in one set. And if we were to multiply this out, it comes out with a really crazy label for this product, 15 times 2/3 plus 1/2. In fact, I'm not even completely sure how to describe it, that this doesn't work, right? Like, what was it? 7/6 yards per set. That's a unit rate, but the 15 yards per bolt is also a unit rate. Now, that's what it was in the actual problem. If we were to analyze it just almost as is, 15 times 2/3 plus 1/2, it would be like saying that you have 15 sets. Let me see if I can make that bigger. 15 sets of aprons. And that's from the numerator. So the numerator is like having 15 sets of aprons. But the problem states, let me change that, sorry, what happened there? It's not, oh. Yeah, so, let's see, so the numerators like having 15 sets of aprons. Yeah, but the problem was, in the problem, it stated 15, and I'll emphasize this, yards for one bolt, not one set. Well, I kind of explained that both ways there. And then the bottom as well. So even just that, right? Dividing it by 5.5, it would be like asking how many 5.5s are in that. So how many 5.5s are in 15 sets of aprons is what that would come out to. But the problem was not asking that, right? So the 5.5 bolts, it was related to the 15 yards, which was for one bolt. So it wasn't asking how many 5.5 yards were in 15 bolts, or even in 15 sets of aprons. It was saying there's 5.5 bolts, 15 yards each. There we go. So we've explained what this one would be asking us to do, or why it would be that way, right? That says diving, sorry. It should be dividing. Dividing by 5.5 is the same as asking how many 5.5s are in 15 sets, but the problem is telling us there are 15 yards in a bolt, and there are 5.5 bolts, which would translate into multiplication instead of division. So hopefully that's a little bit, I don't know if that's super clear on that, but that's why this one would not work, for both reasons. So number 4, how many complete sets can the club make? Well, we already know that they can make 70 and 5/7 sets, right? So they could make 70 full sets and then have 5/7 of a set made of the next set. So really, there's only 70 sets that they could make from this many bolts and yards of fabric, or complete sets, we should say, right? So number 5, if the club makes $10 profit on each set, how much money will they raise once they sell them all? Well, if they can make 70 sets and they were to sell each for $10, that's 70 groups of 10. Sorry, it's 10 right there, which would end up being 700. And of course, this is a word problem, so it needs a label. $700 from 70 complete sets. And, well, that was all. And we showed the work for number 5 as well. On number 4, we just kind of explained the answers that we got in 1 and 2. I mean, we've shown the 70 and 5 sets, so 5/7. So only 70 sets, which would make them $700. All right, and that concludes this reality check.